share my screen?
You should start sharing the screen.
Yeah, I think I will show it. That's easier. Okay, then. Maybe you can see it now.
Yes, we can.
Okay.
So welcome everyone. Yes, Attila, the floor is yours.
Okay, thank you very much. So this presentation is about the arrowheadification of the prototype, which became an AI gym in such way. And I want to give you a short introduction in the first place about the AI tools that are used in this AI gym, because it is very important to understand them in order to servicify these in an arrowhead manner. So in the first place, we have the Jupyter notebooks running by a kernel, which can be IPython or R, it doesn't matter. But these are the basis, the foundation for any AIB solution. So people use these to write their code that can build an AI model or maybe verify it or for the deployment. But data sciences people like me use these things every day to build basically any AI solution. And we have Jupyter Hub, which is a more sophisticated way to handle these scripts, these snippets. And for example, PrototAIP is based on Jupyter Hub as well, and it can integrate these tools, which means that I have an environment that I can run my script, my Jupyter notebooks, and then I can use the same environment to run these and to write these codes. And this environment stores these files locally. So we have files locally that contains all the code that have been used for building and verifying AI models. And in a containers environment, such in PrototAIP, it is more difficult to handle file access, user management, but these are still manageable things. And the problem set, so the main problem is how to create services based on these notebooks that can be used in a local cloud on the top of this ecosystem. And currently, we have two approaches. The first one is the internal API gateway, which means that then I can create a service within a system. And in this case, PrototAIP or the AI gym is the same basically, can be a system within Arrowhead, within a local cloud. And then I can create a service that can be used by service consumers. And then I can use parameters to specify which specific notebook should be run on the server, which means that if I call the gateway, that I can specify the AI model, or more specifically the file that can build an AI model or verify it or deploy it. And the other approach is using standalone services, and this is a little bit closer to the Arrowhead philosophy, which means that I can create services from each files, so I can run each file as a service within a local cloud. And it is a more convenient way to use these files, since if I want to use a script that can build an AI model in different ways, then of course I will know that there is such script in a system, because the Arrowhead, or more specifically the service registry and the orchestrator, can provide information about that. So if I have storing metadata to specify the service that I want to use, then I don't have to know specifically which script that I want to run, only the parameters. For example, I want to use a model for specific purposes that can be, for example, computer vision. I want to identify forklifts or people in industrial environment, and I want to build a model for this, and I want to feed my own data to this model. In this case, I have to only specify what kind of model I want to use, and the orchestrator can give me different choices to use, so it can orchestrate the service for me. If I have to know the specific file, it is more difficult to achieve this operation in Arrowhead, so that's why we use the second approach for this. And another important thing is the universality, which means that these files are created for separated purposes. So I have one file for building a model, I have one file for verifying it, and I have another one for deployment. And I want all of them being capable to be called from the local cloud. So it must be no differences between them. So if I have a file, I want to make it universal, which means that I want to feed my own data, and then maybe I want to get a result, a return value. For example, if I want to identify people in my camera screen, then I can use a model, for example, a built-in model, which can be run by a script in the Jupyter. And in the end, of course, I want to know the specific pixels, for example, where the person is. So I want to get the result from the notebook that I run. So I have to make them callable in such way that I can feed them with an input data, and they can give the result to me by returning a value. So what we had is an architecture which integrates the previous concerns and try to solve the previous problems. And it is the arrowheadified prototype. And as you can see, we have this figure and we have the prototype, which in this case, a containerized service, which is run on a local machine. And we have the aforementioned notebook files. These are the IPython notebook files that contains these specific contents about building models, verifying models, etc. And the arrowheadified AI gene creates services for each of them. So each file has its own service. So if I want to call any service within the local cloud that can build a model or do something, for example, regression for me, then I can specify which kind of model I want to use or which kind of specific task I want to perform, and then the orchestrator gave me the specific service based on its metadata. So basically is the implementation of the second approach that I've mentioned. Of course, we have some Arrowhead specific things related to this. So in this case, the prototype is its own system within the local cloud, and each service that are connected to these IPython files. So basically, the services run the IPython files are within this system. So again, prototype is a system, and these services are in this system. And currently, it is working as it is, but we have some restriction regarding that. So, for example, currently, the solution uses the name of the IPython notebooks as a service name, a service definition in the Arrowhead, and the length of service name is restricted to, I think, 63 characters. So we can't have as many services as we want in this system because the file names are restricted. So basically, we have to modify the structure in a way that it can be named accordingly to its purpose. So not just the file name that we use in the Jupyter Hub, but something basically more meaningful. So that's something that is currently not in the system, but it can be achieved. And since it's open source, all contributions are welcomed. And yeah, I can show you, this is the GitHub repository of the Arrowheadified AI gym that you can reach. And basically, you can see the source code and investigate it. It has very extensive README files, which has a lot of technical details. I don't want to go into technical details because I think that's not the purpose of this presentation. Just to introduce the approach that is used during the Arrowheadification of this AI gym. And just shortly back to the previous slide, how can this be an AI gym? Just I want to give you a short example. For example, I have different files for building a model, as I mentioned, verifying a model, and then the deployment. So I can load the build model and then execute it. And I have separated files for each task. And if I want to create a model, then I can use the first file and feed it my own data via Arrowhead. So I am a service in the local cloud, a consumer service, and then I can ask the orchestrator to give me a service that can build a model for specifically for some purpose. For example, identifying objects in an industrial environment, but I can feed my own data, for example, in the HTTP request, and then it will pass the Arrowhead proxy to the prototype. It will pass the data to the model, and the notebook can use my own specific data to train the model. And for example, it can save the model locally, and then I can use the next file for verifying the model, which means that if I want to verify the model, then I can call it the same way as I did for the first one. And if I want to deploy the model, and if I want to use it in production to identify the forklifts or people in industrial environment from a camera stream, then I can call the search service, but not exactly that. I just can ask the orchestrator to orchestrate me a service that can do that specific task that I want. And of course, I will get the search service in this case, and I can feed the camera stream to the search service, and it will return the result for me. So for example, it's just a binary indicator that there are people on the camera, on the specific frame of the camera stream or not, or it can be more complex. For example, it can identify the picture, the pixel, sorry. So this is the way how we can use it as an AI gym. These are the approaches. And as I mentioned, you can visit the source code and check it for yourself. It has a README, and not just a README, but it has certain test files and Docker Compose file. So basically, you can build a solution for yourself locally. I can say without any modification, you have to generate your own certification for the secure mode. So obviously you can use it in secure mode because that's the purpose of it for using in production. But that's it. Otherwise, it can work out of the box. It has also a test consumer application that you can use. So you can specify which service that you want to use and test it with certain input values, and check it for yourself if you want. And of course, every contributions are welcomed. Okay, I think that's it. Thank you, everyone. And if you have any questions, just please feel free to ask.
Thank you very much, Attila. I think we can stop the recording, and in the meantime, we can have questions.